Hello, this is Ashley from Ashbea Music, and in this video we're going to be continuing our rhythm section of our grade 5 theory paper. We're going to be going through the rest of the section today, which means we're going to be dealing with simple time and compound time. We're going to deal with what I like to call musical maths, which is converting different long notes into shorter notes or short notes into longer notes, and also identifying how many beats are in particular bars of particular time signatures. And we're also going to be dealing with beaming, grouping and rests, which are quite complicated subjects and they end up being quite confusing for a lot of students. So hopefully I can make things a little bit clearer today for students who struggle with those kinds of questions. So without further ado, let's get into it, and we'll begin with converting between simple and compound time. If you have a bar in simple time as your question, you will need to convert it properly into its compound time equivalent. And if you get a bar in compound time, you will have to convert it back into its simple time equivalent. And the most important thing you're going to need to know about this type of question is that you are not allowed to change the rhythm. The rhythm has to sound the same regardless of which time signature you are converting from or to. If you know nothing about this subject, nothing about simple or compound time, we have a video available on our channel. The link should be displayed somewhere on the screen right now, but in case that doesn't work, the link will be in the description below so that you can check out that video if you need to. Let's have a look at what we have here. All right, we have a bar of 3/4 time signature in the treble clef, although the treble clef is not really relevant here because we're dealing with just the rhythm. So you can ignore the clef here because you're dealing with the note values and the groupings and all that kind of stuff. So what do we have here? In our first beat of this 3/4 bar, it looks like we have an eighth note or quaver triplet, right? But the first note is longer than the other one, right? Two of our eighth notes in our eighth note triplet have been absorbed into one crotchet. This is the reason why we have only two notes in this triplet, because one of them is longer than the other. So don't get confused. Triplets don't necessarily always need to have three notes in them. They can just have one longer note and one short note. So that's what we have here in beat 1. In beat 2, we just have two regular quavers. And in beat 3, we have a crotchet. So we need to learn how to take all of these different types of note values and convert them into their compound time equivalents without changing how the rhythm will sound. And as I said, there's more detail in that other video that I told you about. But for now, let's just take a quick refresher on what we need to do to convert between simple time and compound time. So the first thing we need to do is to take our time signature, which is 3/4, and convert it into its compound time equivalent. So the top number needs to multiply by 3 in order to get its compound time equivalent, and the bottom number needs to multiply by 2 in order to get its compound time equivalent. So 3/4, which is 3 crotchets in the bar, turns into 9/8, which is 9 quavers in the bar. But that is not necessarily how we count our beats. And once we actually realize how compound time signatures work in terms of their beats, we can actually realize why we can convert these two time signatures into each other without changing what the rhythm sounds like. Let's have a look at all the individual note values and what they turn into in their corresponding time signatures. So I'm going to draw a percussion clef here, which is simply what we do when we don't have any notes that go up or down or higher or lower notes, but we're just dealing with rhythms. This is the clef that we use. I've put the simple time signature over the top here, and I've put the compound time version on the bottom. Let's deal with the simplest of the note values first. So in 3/4, we're dealing with 3 crotchets in the bar. So I'm going to draw out a bar of 3 crotchets and draw a bar line. In 9/8, we take this exact same set of note values and put them into the 9/8 bar, but we have to make one small change. We have to add dots after each of these notes. Okay, so 3 crotchets in our 3/4 time signature turns into 3 dotted crotches in our 9/8 time signature. So even though we do have 9 quavers in the bar, we don't actually count 9 quavers. We actually count the 3 dotted crotches. So 3/4 has 3 beats in the bar, but 9/8 also has 3 beats in the bar. In 3/4 we'd get 1, 2, 3, and in 9/8 we would get 1, 2, 3, 4, 5, 6, 7, 8, 9. In simple time, our beats divide into 2s. So for each of these crotchets, we have to divide it into 2 quavers. We have this 1 and 2 and 3 and 1 and 2 and 3 and. This is our normal division in simple time. So simple time, each beat divides into 2 parts, and in compound time, each beat divides into 3. So in our simple time signature, dividing into 2 is the normal and accepted way of dealing with divisions of your beat. Whereas in compound time, we divide into 3, and dividing into 2 is something that actually breaks the rules. So what do we do when in one time signature 2 is the normal grouping and in the other time signature 2 is the abnormal grouping? It's not the normal thing and we are actually breaking rules. Okay, so what we do with this is we still keep the note values the exact same, but we have to put something on these note values, like a sign or something, that will show us that this is actually not normal and we are temporarily breaking the rules, even though it's still going to fit into our time signature. What we do is we take these note values and we put a 2 on top of each of these. This turns normal quavers into what we call duplets. So this means 2 notes in the time of 3. In our normal group of 3 within our compound time signature, we're actually only going to get 2 notes, which means that each of these duplet notes occupies 1.5 beats, because that's how we divide 3 into 2. 3 divided by 2 gives you 1.5. This is how our 9 quavers divide into our 3 dotted crotchets. And if we just want to count the 3 dotted crotchets, we have to make sure that we put each of our numbers 1, 2, and 3 on numbers 1, 4, and 7 of our actual quavers. Okay, so we have 1, 2, 3, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, which ends up being 1, 2, 3, 2, 2, 3, 3, 2, 3, if we were dividing it into 3 parts. So how does this work with duplets? So we have 1, 2, here's the and, so this second part of the duplet actually comes in on the and of beat 2, and then we do the same thing for each of these other beats. So you notice that the duplet comes in on the and after the second beat of whatever group you're on. So now we get 1, 2, 3, 4, 5, 6, 7, 8, 9, and then if I were to count duplets, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, which is the same as 1 and 2 and 3 and in our simple time signature. So this is how that works. So what do we do when we have to deal with groups of 3? Groups of 2 are normal in a simple time signature, but groups of 3 are not. Turns out we have to do a very similar thing with the groups of 3. We actually have to show that they're not part of our normal grouping in our time signature. And just like we put the 2 above the duplet for the compound time signature, we have to do that for the simple time signature, but this time we put a 3 because we're showing that we're using in a group of 3, which is not the normal grouping in our time signature. This is how it looks for 3/4. And then for 9/8, of course, we don't change how the rhythm looks, because if you change how the rhythm looks, it changes how it sounds. And this is the reason why all of these note values stay the same. And we only put little signs on top of those values to indicate whether they're normal or abnormal, or whether the beats have changed or not. So you'll notice the types of notes we're using have not changed at all. all we're doing is adding little bits to them, or taking little bits away if we're going the other way around, to make sure that the rhythm stays the same when we convert the time signature. Notice how the groups of 3 here in the 9/8 time signature are normal. Okay, so we don't have to put any strange markings on top of them. And now you can see how the two time signatures are actually quite similar to one another. You can put the same types of notes in both time signatures, but what you have to do is indicate which ones of the groups are not the normal groupings for the time signature. So this should be everything you need to know to convert between simple time and compound time. Let's go back to our question now and see if we can work this out. What do we need to do based on what we just worked out? We know that in 3/4 we're allowed to put the triplet sign to show that we have a group of 3 where that's not normal. But in 9/8, groups of 3 are normal. So what we need to do is remove that triplet sign. In our second beat, we have a group of 2, which is normal in 3/4. It's normal in our simple time signature, but it is not normal in our compound time signature. So we need to make sure that we indicate that that group of 2 is different to our usual rules for how we divide the beats in that time signature. And then the note that is on its own at the end, the crotchet at the end, is going to get a dot. So these things are the things we need to look for when we deal with this question. 2 of the details were correct in option A, only 1 is correct in option B. So that means that C is our correct answer, and let's see why. This first beat here is part of a group of 3, which is normal. So we do not need to put any number 3 on top of that group. So that's just normal notes. That's absolutely fine. The group of 2 is not normal, so we do need to indicate that it's a group of 2. That is also correct. And then, of course, on our crotchet, we have the dot, which turns the crotchet from its normal simple time beat into its compound time beat. So all 3 of these details are correct. You have to really watch out for your details on this one, because if you miss anything, you won't get the mark for the question. So yeah, that's how you deal with this question. Let's move on to the next one. 1.3. Okay, these questions deal with what I like to call musical maths. What you can do with different types of note values is you can combine them and split them apart. And what this question tests is, do you know, first of all, how many beats are in your bar for different types of time signatures, whether they're simple or compound time? And we did cover that just now with 1.2, but 1.3 can give you questions in which you will have to know what your beats are in your time signatures and how to express them properly. In our first question, we have a time signature, and it's asking us how many beats are there in a bar. So let's have a look at this first one. So we have our time signature of 6/4, which is 6 crotchets in the bar. But the question is asking me how many dotted minim beats are in a bar. And that is because of what we talked about in the compound time question that we just had, where even though we have 6 crotchets in the bar, we're not actually counting all 6 crotchets. We're only counting how many groups of 3 there are, and that is actually our beat. So the beat falls at the beginning of every single group of 3 in a compound time signature. So the actual beats we will be counting are in the beginnings of each half of the bar. In this particular time signature, you will get 1 beat at the beginning of the first half of the bar and 1 beat at the beginning of the second half of the bar, meaning there is going to be 2 beats. And each of these beats is actually indicated by a dotted minim, because 3 crotchets equals 1 dotted minim. So this is why the question is asking you, how many dotted minim beats are there in a bar? Another way to express this question is they're asking you how many groups of 3 are there in this time signature. because that will equal your number of beats, as we talked about earlier. The next question deals with either combining shorter notes into longer notes or splitting longer notes into shorter notes. But you got to make them equal. That's why the question says, in this particular question, we say a double dotted quaver is equal to how many demisemiquavers. So you need to figure out how to get the two note values to equal the longer note, right? So one double dotted quaver is just one double dotted quaver. And dealing with your dotted notes, remember what we talked about in our previous video, a dot adds half of the value of whatever came before it, whether that's another dot or a note. Okay, so anything that comes before a dot adds half of whatever just came before it. So in this case, we have the quaver, we have a dot, and we have another dot. Okay, so the quaver is just a quaver, and the dot will add half of a quaver, which is a semiquaver, and then we have another dot here, which adds half of whatever the dot was. Half of a semiquaver is a demisemiquaver. So on the left-hand side, we have our double dotted quaver, and on the right-hand side, we have the maths that we need to do to try and see how many demisemiquavers we need. But we haven't actually gone all the way yet, because now we need to convert each of these different types of notes into demisemiquavers and find out how many of them there are. So the quaver splits into two semiquavers, and the semiquavers split into two demisemiquavers each. Now that we've worked that out, we know that the quaver is worth 4 demisemiquavers. The semiquaver is worth 2 demisemiquavers, and then obviously one demisemiquaver is just one demisemiquaver, right? 4 plus 2 plus 1 is 7, and that is how many demisemiquavers the double dotted quaver is worth. So that's how many shorter notes you can split that longer note into in order to make the duration of time that that note occupies exactly the same, whether it's kept as a long note or divided into short notes. Cool, so that's that question. Let's move on to the next one, which is 1.4. These tend to be a little bit trickier for students because now 1.4 and 1.5 deal with beamings, groupings, and rests, which tend to be more complicated than the other questions. What we need to do here is we need to figure out which bar is grouped correctly according to whatever time signature they've given you here. So here we have a 4/4 time signature, which is 4 crotchets in the bar. Each of these 4 crotchets divides into 2 quavers. However, we have some really important considerations for even numbered time signatures. It's not just about how many crotchets you have in the bar. You also have to take into account that the middle of the bar is a really important landmark for any time signature that has even numbers of beats. So there's our middle of the bar. The most important thing, one of the most important things in even numbered time signatures is you do not cross over the middle of the bar, because musicians are looking for that middle of the bar in order to make the rhythm make sense. It enables musicians to read things quickly when they can see that things are evenly split into one half of the bar and the other half of the bar. It's important to not cross over the middle of the bar because your rhythms end up being confusing to read. But even though our crotchets divide into 2 quavers each, we can actually do some extra things with the grouping here, which will not violate that middle of the bar rule. So what we can do with our quavers in 4/4 is, instead of keeping each one in its own separate beat, as long as we do not cross over the middle of the bar, we can actually beam more than one quaver together. In fact, we can beam up to 2 beats together, like this. Even though I've not beamed our quavers according to their individual beats here, you can still see where the middle of the bar is, because there's a very clear break between the first half of the bar and the second half of the bar. we can still clearly see what the rhythm is, even though we've beamed more than 2 quavers together. In fact, that actually makes the rhythm easier to read. However, when it comes to semiquavers, we do have to keep them in groups of 4, because otherwise it will become more confusing to read them. So our semiquavers are grouped in 4s. They're grouped according to individual beats, because otherwise we would have too many notes to read in one group and things would get confusing. So this is how we deal with crotchets, quavers, and semiquavers. So let's see if we can identify which of these options is the correct one. Let's have a look at our first option. Because we're dealing with 4 crotchets in the bar, I'm going to be converting shorter notes into their beat notes. So I'm going to be converting quavers and semiquavers into crotchets in order to figure out A, whether we have the right amount of beats, and B, whether they are in the right grouping. Here we have 2 quavers, that equals 1 crotchet. These 2 semiquavers equals not a crotchet, it's actually a quaver. I can immediately see that there's an issue here. Right? We've got 1.5 crotchets before we get a break. We need 2 crotchets on one side of the bar and 2 crotchets on the other side of the bar. And then here we have another 1.5. This rhythm is not written in the correct way to make a 4/4 time signature easy to read. This first option is not going to be our correct answer. Let's have a look at our second option. The first 2 quavers equal a crotchet, and the reason why we're not beaming more than 2 quavers here is because we have a mix of quavers and semiquavers. Notice in the example that I provided earlier, I was only dealing with either quavers or semiquavers. The moment you get a grouping that contains both semiquavers and quavers, you have to apply the rules of semiquavers. For example, in our second beat, we have 2 semiquavers and 1 quaver. You must follow the groupings of semiquavers in order for that to make sense. So here we have 2 semiquavers, which is a quaver, and then 1 other quaver, which equals a crotchet. And then we get the middle of the bar, which comes after 2 crotchets, which seems to follow our rules. Our next beat, the third beat, contains 4 semiquavers on its own, which equals 1 crotchet, and then we have the 2 quavers at the end, which equals 1 crotchet. So it's looking like B is the correct option, but I just want to verify that by looking at the last one and making sure that that one is not the correct one. And I can immediately see a problem. We have 1 quaver on its own. Now, normally 2 quavers need to be beamed together in order to equal 1 crotchet. So having 1 quaver on its own and then the other quaver beamed into a group that we can't actually start because we haven't finished the previous one, well, that's wrong. We have to finish each group that we start before we start a new group. So this quaver being on its own is already a bit suspect. But then we start a new group with a bunch of other notes before completing the beat to which this note applies. So these 2 quavers should have been beamed together. The semiquaver and the quaver should have been beamed together in their own group. Here we have an issue as well because we have 2 semiquavers beamed together, but remember what we said about semiquavers. We need 4 of them to equal a crotchet, and we need all 4 of these to be beamed in one group. And then here we have the 2 quavers, which is fine. We have now verified that the middle option is our correct answer. Okay, so let's deal with the last question in this section, which is 1.5. In this question, you need to either tick or cross each of the boxes underneath each of the bars in the question to show whether the rests are correct or incorrect. This is not just about rests. This is also about groupings and whether you know them. They may look confusing, but it's actually easier than you think. Let's have a look at what we have here. We have a piece of music that has a 4/4 time signature, and if you don't know what the C is, it's basically a shortcut for writing 4/4. So We have a 4/4 time signature, and then we have 3 bars of music. But we need to figure out whether these rests are correct within the bars. We have beat 1. This minim rest here handles beats 2 and 3. And then we have a crotchet which handles beat 4. Now, is this correct? Well, in our previous question, we talked about how even numbered time signatures have to be grouped into each half of the bar. We can't cross over the middle of the bar. This is why we have an issue with this bar, because our minim rest that we have in the middle of the bar actually goes over beats 2 and 3. It goes over the middle of the bar. So if this were correct, it would have had to be 2 crotchet rests instead. We're not allowed to put a minim rest at the beginning of beat 2 because it goes over the middle of the bar. So this bar is incorrect. Let's have a look at the next bar. So we have a group of 2 semiquavers and a quaver, which equals 1 crotchet. That's fine, that's beat 1. And we have an interesting problem in the second beat. Here we have half of our crotchet, half of a beat, but then we only have a semiquaver rest. So this is 3/4 of a crotchet, this group. And then we end up with a quaver rest, making that even longer. This is why this is incorrect. The correct way to handle this is to finish the beat that you've only got half of, or a partial amount of. You must always try and finish each beat before you move on to the next beat. So since we only have half a crotchet, we would actually need to have half a beat of rest before the next beat starts. So what's actually happened in this bar is these 2 rests have actually been swapped around. This quaver rest should have gone here, and this semiquaver rest should have gone with this group of 3 semiquavers to make 4 semiquavers. That way, each of our groups would have equaled 1 crotchet each. And with our third bar, we have a quaver and a quaver rest. That equals a crotchet, that's fine. We have a quaver triplet, which is 3 notes in the time of 2, and we have a quaver rest within that triplet, followed by a crotchet. So we have a short, long kind of rhythm within this triplet. So that's also fine. Since we have our 2 crotchets, we need to check for our middle of the bar. Are we crossing over it? In a way that is allowed, yes. And we need to talk about that. Anytime you want to cross over the middle of the bar, you have to keep each half of the bar separate, but you are allowed to cross it if you're using a tie. In fact, that is the only correct way of crossing over the middle of the bar. If you want to make a longer note, but you do want it to go across the middle of the bar, you can't just write a long note and call it done, because that is going to be incredibly confusing to count, and it's going to be very, very confusing visually to see. The way you keep each half of the bar separate and still allow long notes is by tying notes over from the first half of the bar to the second half of the bar. And this is what we have going on here. We've got that crotchet as part of the quaver triplet being tied over to a minim in the second half of the bar. And because the middle of the bar is still visible, even with the tie, this is still correct. So that's still working really well. Remember what we said about our grouping in even numbered time signatures, particularly for 4/4, we need 2 beats on one side and 2 beats on the other side. And this minim takes up the entire second half of the bar. It takes up the entire right-hand side of the bar. So in this case, we are absolutely correct in how the grouping is handled. So this bar is actually fine. And that's how you handle this question. Thank you for watching this music theory video. There will be more videos in this series, so subscribe if you don't want to miss any. And if you want to join our music theory live course, check out the details in the description below. See you next time.